All right, let's take a look at our lesson for today. All right, so we're learning a new formula. I know you're excited about this. This is the average value formula. So let's talk about the formula just itself. So if I want the average value of a function, now this is a different formula than the average rate of change. I'm just going to write this up here. Average rate of change is a different formula than the average value. Do we remember average rate of change? Right, f of b minus f of a over b minus a. That's the average rate of change formula. This is the average value formula. And we're not necessarily going to know which one to use by just the word value or rate of change. So let me explain how we know which one to use. This is significant. Before now, if it said average, you would use the average rate of change. Now we have a choice of two different formulas. So how will I know what to use? If I want, and this is a significant part, if I want the average of what I have, this is this is what I have. The equation or formula. It's not really an equation, the expression. Okay, if I want the average of what I possess, which is this expression, then I use this formula. That's what I do. If this formula is temperature and I want average temperature, I'm going to use this formula. If this F stands for, let's say it stands for the rate of change of, the radius. If it stands for the rate of change of the radius and I want to know the average rate of change of the radius, then I'm going to use this formula, not the rate of change. If I have F and I want the average rate of change of F, that's when I use this one. The average rate of change of F. Average rate of change of F, I use that one. Okay, and we'll encounter this several times, but when I first introduce it to you, I need to make sure we understand that we now have two formulas to pick from. So what does this average value formula do? It's 1 over b minus a times the integral of a to the b of f of x. Okay, so what does it do? Let's look at a picture of what it does. Basically, what we're doing is we're finding the average y value. We're finding the average y value of the function. That's what the formula does. It's as if it could add all the y values up and divide by how many y values there are. That's like a scenario. Like that's as if that's what it does. So what you're seeing right here is this C right here is the average y value. They're showing it to you in, it's still in a curve. And they're trying to explain that if I were to take this area up here and this area right here, and I were to put it all under the line, it would all fit right there. That's what this is showing you. It's just conceptual. There's nothing that you need to memorize or anything. It's just a conceptual, something like a concept, okay? So that's what this formula does. It calculates the average y value of a function, okay? So let's look at our very first example. They want us to find the average value of that, of f is 6 minus x squared, on -1 to 3. Okay, so let's do that. So average y value. So here we go. We're going to use our brand new formula. So it's 1 over 3 minus a -1, integral of -1 to 3 of 6 minus x squared dx. Okay, that's what we're doing. All right, so let's do some antiderivatives. We're going to do our reversal power rule. What is this? 3 minus 1, that's like 1/4. Okay, so we're doing our reversal power rule. So the antiderivative of 6 would be 6x. The antiderivative of -x squared would be what? -1/3 x cubed. and I want to evaluate that from -1 to 3. Okay. So just continuing on, I really like to reserve, like this fraction. I like to leave it out because, again, numbers are not easy for me. So I'm just going to leave it out, and I'm going to say, put my 3, so 6 times 3 minus 1/3 times 3 cubed minus, so that's f of b minus, and I guess we need big because that 1/4 belongs to all of that. Then I put in a -1, that's 6 times -1 minus 1/3 times -1 cubed. And now it's lovely arithmetic. If this were on the AP test, we would stop here. We would not do arithmetic. You with me? We would stop and just box it. Okay, right now we're just going to go ahead and continue. So let's see, 6 times 3 is 18. 3 cubed is what, 27? Minus, that's what, -6. A -1 cubed is negative, so that would be plus 1/3. Okay, so y'all know that I'm not good at arithmetic. If you see something, let me know. We okay so far? I think so. 27/3 is what, 9, right? So I've got 1/4. I've got 18 minus 9 plus 6 minus 1/3. So what is that? That's what, 9 and 6 is 15. So I have 1/4 times 15 minus 1/3. What is that? So 15 is 45/3, right? 1/4 times 45/3 minus 1/3. That would be 1/4 is what, 45, and so 44/3, which is 11/3. That's a lot of arithmetic. Hopefully I did that fine. Oh wait, did y'all see any bad arithmetic? Okay, I'm going with it's okay. So the question is, when does the function assume this value? All right, so our average, let's make a note here. This is our average y value. That's what we just found. This is the average y value. Okay, 11/3 is the average y value. So let's plot 11/3 up here. 11/3 is what? 3 2/3, right? 9, 10, 11, 3 2/3. So like around here. So it happens here and here. Visually, that's where it happens. If we want to know exactly where it happens, what do you think we would need to do? Yeah, plug it in, right? That's our average y value. So we would want to, so that's around, that happens twice, we can see. So I would just say, what's that, 11/3? So we would say 11/3 equals 6 minus x squared. And so I like to keep the x positive, so I'm just going to move things around. So I've got x squared equals 6 minus 11/3. So what, that 6 is what, 18/3? So x squared equals 7/3. So x would be plus or minus square root of 7/3. That would be when it happens, which is these two strange places right here. Okay, so that is average value. How are we doing? So I've used the formula. We recognize, I'm hoping that what we found was the average y value. If they ask us, like they did here, when does the function assume the average y value? What we have to do is we have to take the average y value and sub it into the formula, okay, and then solve. And that tells us when. Okay, are we all right? Okay, here we go. So we're going to, for 2 and 3, we're going to use our calculator because I think we had some good practice with anti-derivatives by hand. Now we're going to utilize our calculator. So let's set this up and see what's going on. All right, so let's see. So H, this is height. This is a position. This means height, and T is time. Okay, great. If we want, so let's go with this. If we want average height and we have the formula for height, which equation or formula will we use? We have height and we want average height. Is that average value or average rate of change? It's value. It's average value. We have the equation that we want the average of. Okay, so here we go. So the first 3 seconds. So I have, let's talk about, so the first 3 seconds. So I'm going from T is 0 to T is 3. That's what I'm doing, right? And this would be A, and this would be B. And that's how it works, right? A is the smaller one, and B is the larger one. I'll just erase that. So this is A, and this is B. All right, so 1 over 3 minus 0, integral 0 to 3 of negative 16t squared plus 41t plus 10 dt. And now we're going to go to our calculator. I'm going to pause here for a second. Is everybody okay? Okay, so let's go to our calculator. And I'm just telling you, when I pull the calculator up, I'm not going to be able to see this document, so I'm going to need y'all's help to tell me what to put in the calculator, okay? All right, so let's pull the calculator up. We want to use the calculator. Several ways to get to the integral. One way is this way. You can do it by pushing that little button and then going to this right here. Okay, so we're going from... And actually, I want to go ahead and put my fraction right here so I don't forget. Was that 1/3, right? Okay. And then we were integrating from 0 to 3. Now this is the part, I think it was like negative 16, wasn't it? Negative 16. And I'm doing x's, not t's. The calculator doesn't care. And then what was it? Minus or plus? Plus 49t? Oh, 41, thank you. And then? Plus 9? Plus 10. Okay. All right, so we'll let that. And I want it to, I don't want a fraction. Let me put a decimal somewhere. I want to put a decimal right there so it gives me a decimal. Okay, 23.5. All right, so we've got, this is 23.5, or we'll just put in decimals, 23.5. And it's average height. And so what would our unit be? Always write your units.
Did you already do the 1/3?
Yes, I like to, because I forget, I like to put it in the front in my work right here so I don't forget. Okay. So what is our units here? What? Feet? Okay, so that's our average height during the first 3 seconds. Okay, so now it wants average velocity during the first 3 seconds. What do we think that means? Which formula am I going to use now? Average rate of change. I'm going to use the average rate of change formula. Yep, totally. So let's do, it would be H of... So you know which averaging formula to use by what equation you're given. Okay, we always have to go off this equation. This equation represents height. So if I want average height, I have to use average value formula because it wants the average y value. But if I want the average rate of the equation I have, then I need to do average rate of change formula. Okay? So h of 3 minus h of 0 over 3 minus 0. Okay, so we're going to go to our calculator. All right. So we may or may not have talked about this before. I don't remember, but I'm going to show you how to store an equation in here. So the equation was negative 16x squared. Was it, help me with it, was it plus 41x? Plus 41x. And then what was it with 10? Was it plus or minus 10? Plus 10? Plus 10. Okay. I'm going to store this in the calculator. See this little blue store button? So control store, and I need to actually name it a function. I need to make it, I can't just say, I don't know, like h. I am going to use h, but I have to do h of, like that, x, right? I have to store it like that. And then I hit enter, and it's stored. So now what I'm going to do is I'm going to actually put my formula in. Okay, so here's I'm doing my f of b minus f of a. So I'm going to do, I get to my stored stuff by hitting VAR. It's h of, what was it, 3? And then minus h of 0 over 3 minus 0. And I want it to be a decimal, so I'm going to put like 3 minus 0. Okay, that's going to be way easier than me sticking a 3 in here and then getting that number and then sticking a 0. You with me? I'm letting the calculator do all the work for me. And so it's negative 7. Okay, are we okay with that calculator input? Yes? Okay, so let's go back to our document. So this is negative 7, and this is a rate. It is a rate that the height is changing, right? So it's going to be what? Negative 7 feet per second, right? It's the rate. And that's number 2. Okay? All right, let's look at number 3. We're still going to be utilizing the calculator. So this is something important. What information do I need to show when I am using a calculator? Because you will. So what do I have to show? I have to show this whole thing and nothing else. I highly encourage you to not do the antiderivative by hand when you have a calculator. But you do have to write it out, what you're putting in the calculator, like that. You got to write that out. Okay, in this, you've got to show the formula. I mean, you've got to write it all out, and then you're fine. Okay, so now let's look at the next one. So we've got, let's see, r is 2 sine x minus 1, where r is the rate. R is the rate at which Mr. Bear's waistline is changing, inches per month. It's a rate. Inches per month. That's quite interesting. I'm really not sure who wrote that, but
Do you not make these?
no. I get them from different places. I like them. I see them, and I said that's a good example, and so that's why we're doing it. Now I didn't I mean, I could have changed the scenario if I wanted to change it to something else. I don't know. What you know, where R is the rate that, I don't know. Whatever. You can make up whatever you want, right? It doesn't matter. So now let's try to decide what we are going to use, what formula we're going to use. What is the average rate of change that Mr. Bear's waistline changes? Okay, so hold. So our formula is the rate his waistline is changing. We want the average rate that his waistline is changing. Which formula am I going to use? Average value, because I want the average of what I possess. We have to get that in our, like, linked together in our brains, right? If I have the rate the waistline is changing, and I want the average rate the waistline is changing, I'm doing average value, even though it has rate in the prompt. Can you see why students would get confused and want to use f of b minus f of a or b minus a? You with me? It's tricky. Y'all are like, great, it's so tricky. We love tricky. Okay, so average rate. of change. We have the rate at which it's changing. We want the average rate of change. So it's from the 10th to the 12th month. So X is time in months. So let's translate this. X is time in months. So that means that X would be 10 and X would be 12. That's the time in months. So I have 1 over 12 minus 10, integral 10 to 12 of 2 sine x minus 1 dx. Okay, we're going to go to our calculator. Maybe I could just try to pull this up on my other, so I don't have to ask it all the time. Okay, there we go. I got it up here. So let's go to our calculator. Okay, so I'm going to store, because I'm probably going to need this formula again. I'm going to store that formula. So I first need to be sure I'm in radians, which I am. Please be sure you're in radians. I had a student work their whole test yesterday in degrees, and they didn't realize it till after they were done. I felt really bad. Please be sure you're in radians. Okay, so here we go. So we're going to store 2 sine x minus 1. And I'm going to store it as r, because that's what they call it. So I'm storing it as r. Again, you have to store it as a function, r of x. Okay? There we go. It's done. All right, so now let's put our formula in. So I'm going to go ahead and do control divide. I'm going to put my 1, let's see, 12 minus 10 is 2, right? So 1 half. Then I'm going to use this little button to get my integral formula down from 10 to 12 of r. I already put it in there, r of x dx. Well, let's hope it gives me an actual decimal. Of course it doesn't. Let's see, where can I put a decimal? Okay, perfect. Let's just do that then. Okay, will it do it from here, control enter? Let's try. I don't know. Yeah, it does. Great. Okay, so negative 2.683. So we want to go 3 decimal places. So negative 2.683. Let's write that down. All right, so that is negative 2.683. Well, his waistline is changing down. Okay, that's better than going up, right? I think so. I mean, I would rather my waistline decrease than increase, but okay. The rate of change. So the average rate. So this is the average rate of change. So it's negative 2.683 inches per month. Okay, are we okay? All right, what is the average change? Oh, look at this. They're being tricky. What is the average change of this rate? What in the world? That's worded weird, isn't it? The average change of this rate. They want the rate of the rate. You with me? The change of the rate, which is crazy. What is the average change of this rate? So what formula am I going to use? F of B minus F of, yeah, I'm going to use that formula. Okay, so we've got what's called R. So we've got R of 12 minus R of 10 over 12 minus 10. We're going to go to our calculator. We've got it stored, thankfully.
Why do you not use 5?
Use which one?
It says it's during the first 5 months.
Ooh, where do we go? Let's go back here. Yes, I thought it was going 10 to 12, but you're right. It's during the first 5 months. What is the average change of this rate? during the first 5 months. Let's go back. Yeah, it's average. So so let's read this again. What is the average change of this rate? The average change of this rate. It is still the same formula, but with the first 5 months. So 1 over 5 minus 0, integral 0 to 5 of r of, do they use a t? R of x dx. And it is certainly okay to just put the name down instead of rewriting the formula. Actually, it would probably be advisable to use the name when they name it. Just name it. It saves you time and the chance that you will, accidentally write down, miscopy something. Average change of this rate. Average change of this rate during the first 5 months. Okay, here we go. So we've got, what was it, 1/5.
Dr.
Uh-huh.
Why wouldn't you just do R5 minus R0 over 5?
Okay, let's go back.
Like this.
Let's talk about it again. Okay. So this formula right here, represents the rate the waistline is changing. That's what it represents. The rate the waistline is changing. Okay. So if we want let's say we wanted to know what was the rate that the waistline was changing at 5 months. We would plug in a 5 into the formula, into this formula, right? With me? If they asked us what was the rate that the waistline was changing at 5 months, we would plug in a formula. But they want the average change of the rate. Okay. What is the average rate of change? What is the average change of the rate? Same, it's rate and change. They just mixed the words up. I don't know why. To be confusing, probably. What is the average change of the rate? What is the average rate of the change? It means the same thing during the first 5 months. So we want the average of the change, not just the change. Does that make sense? Okay, you're welcome. So let's go here. And so we're going to use our little integral thing. We're going 0 to 5 of r. Wait, yeah, it's r of x. And control enter, and it's that. So his waist is changing at a rate of down 0.7 pounds the first 5 months. But if you take, so I guess his weight is changing faster. Do you see what I'm saying? It's going down quicker between months 10 and 12 than it was between months 0 and 5. Ooh, we could write, I don't know, we could write some kind of rate for, I don't want to talk about my waist changing, but it's entertaining. All right, so this would be, was it negative 0.7? I missed the other part of it. What was it? 1.3. 7.13. And that would be inches per month. Okay.
So the reason we didn't use rate of change was just because the formula is already a rate?
Yes, because the formula is already a rate.
Okay.
Okay, so since this is the sticking point here, let's it's not on this example, but let's talk about what words would they use if they wanted to do f of b minus f of a or b minus a. What words would they use? They would say, what is the average rate of the rate at which Mr. Bear's waistline is changing? Okay, what is the average rate of the rate that which Mr. Bear's waistline is changing? That's the words we would need to use f of b minus f of a or b minus a. You with me? Do we need to write that down? Yes? Okay, so let's just put, so it would say, what is the average rate that the rate at which Mr. Bear's waistline is changing? And that would be R of whatever, B minus R of A over B minus A. So it's the average rate that the rate. Okay, so if we want the rate of what we have, and what we have is the rate, we would use this formula. So I want to pause there for a second because I know it's confusing. What is the average rate that the rate at which Mr. Bear's waistline is changing? We would use that formula. Okay? All right. We good? Okay. So the last part of this lesson has to do with these formulas that I've been highlighting in yellow forever. Right? The formulas for integration that we've been highlighting in yellow. We're going to practice these formulas and I want to talk about them. So this gives us a lot of freedom, actually. This location, so A is a number. A is a number. U is a variable. That's what they are. A is a number, U is a variable. So if we have 1 over A squared plus U squared, we can integrate it as this, 1 over A arctangent U over A plus C. I want to point out some similarities and differences between our formulas here so that hopefully it might help you memorize. First of all, if you notice, every single one of them in the argument of the trig, the inverse trig, is U over A. They're all the same, U over A, U over A, U over A. The only difference is this one, arcsecant, has absolute value U over A. Other than that, they're all identical. I want you to notice the number in front. This one has a 1 over A, arctangent. Arcsine does not. Arcsecant does. This one is missing. So as you're memorizing, keep in mind that this one is missing. It doesn't have the 1 over A out in front of it. Okay, so these are the inverse trig. So I'm going to pause here for a second. So the thing students get confused with is, first off, they are confused about what A and U are. A is the number, U is the variable. And then students typically get confused on the beginning. Like, what am I going to, do I have a 1 over A in front of it or not? And so that's the, they both, 2 of the 3 have the 1 over A in front of it. Okay, so with that, let's practice. We're just going to practice rewriting, transforming this to match one of the formulas above. Okay, so this one, would it match arctangent, arcsine, or arcsecant? Arcsecant. This would be arcsine. All right. So, so let's figure this out. So this spot right here is the number. So if it's A squared, then, and this is just a 7, then A squared would be the square root of 7. Right? A squared. Hold on, let's see. Hold on. So we just want what A is. A is the square root of 7. That's what A is. And then when I square it, I put the 7 right here. So A is the square root of 7. Okay, are we okay? Let's out to the side, let's do one that's easier at the same time. Okay, so let's do one let's make that. Okay, we're going to do them at the same time. This one, a would be the square root of 7. On this one, what would a be? 2. See, that's much easier, right? We like it when they're perfect squares. On this one, u would be the square root of 2 and then an x, right? Because that's what u would be. On this one, u would be what? 3x. Now, why would I care about that? I care about that because that gives me the answer. I only need to know what a and u are, and I can just solve it. I mean, we can just write out what the answer would be. If I'm doing the antiderivative of this, we agreed it's arcsine. I won't put the 1 over root 7 here, right? I won't do that. But u is the square root of x. So I would have to do, du equals square root of 2 dx. 1 over square root of 2 du equals dx. Okay, so I would, because of what u is, I have, my answer is going to have the 1 over square root of 2 arcsine of square root of 2x over square root of 7. Move this over. Y'all are like, you're so crazy. What are you even doing? Come on, you can move. Okay, plus c. Okay, here, du would be 3 dx, 1/3 du equals dx. So I am going to have the 1/3 out front because of this. So the reason I have this 1 over root 2 is because of this, not because of the formula. And the reason that I have this 1 over 3 out front is because of this, not because of the formula.
So
This would be
the arcsecant one. Would you just multiply the 1/3 by like 1 over?
by 1/3, right? Yeah, you would. Arcsine of u over a, so it would be 3x over 2 plus c. So that's why these formulas are very significant, is because they basically give us the answer. And if you know the formula, you can integrate by just filling in the blanks. Okay, is that okay? Okay, so now we've got one example where we actually do use the formula to find the average value. Okay, what's the average value of? So we've got 1 over 3 minus 0, integral 0 to 3 of 5 over 9 plus x squared dx. Okay, I'm going to rewrite this to take the 5 outside just because I like it better. So 5/3 integral 0 to 3 of 1 over 9 plus x squared dx. Okay. So let's look at these formulas. Which one is that one? Arctangent, arcsine, or arcsecant? It's arctangent. It's arctangent. So let's write just over to the side right here like scratch work. So a is 3 and u is x. So there is no u sub here. So it's just straight up formula. So we have 5/3. So times. So the antiderivative, we're doing this formula right here. Okay. So I've got 1 over a. So I've got 1 over 3. I've got arctangent of u over a, so x over 3, evaluated from 0 to 3. So I'm going to pause it for a moment, make sure we're all okay. Are we okay? Okay. So now I'm going to get these, I like to get these guys together because, you know, fractions. So that would be what, 5/9? And that would be arctangent of 3/3 minus arctangent of 0/3. So let's think about what that means. Okay, I'll put my like unit circle thinking up here. So I need to know arctangent of 1 means where, at what angle measure would tangent be 1? That's the question that's asking us. At what angle measure would tangent be 1? Pi over 4. So I have 5/9 times, I've got pi over 4 minus. Here, at what angle measure would tangent be 0? Sine over cosine, sine will be 0, cosine will be 1. At 0, we have to use principal value.
Wait, so 0 is where tangent equals what?
Yes. No, 0 is where tangent equals 0. This
Yeah.
one.
Yeah.
Yeah. Arctangent of 0. So at what angle measure would tangent be 0? It would be at 0 radians. I mean, or pi, but we have to choose principal value, which is 0, not pi. So then my final answer would be what? 5 pi over 9 times 4. What is that? 36. And there we go.
In this question, why is A 3 and UX if there's no square root?
Y is A, so we're looking at this, and this is A squared, so that means A would be 3. And this is, come on, you can do it, U squared, which means U would be X. Okay? Okay.